Right, let's have a look at this then. Here's the data, here's the formula it's supposed to fit, and we're asked these questions when we've fitted the data as accurately as we can. So here we got time, we want a linear relationship, isn't it? So we're going to need to take logs to base e, because there's an e to a power. Theta minus 20 would be best to do first, wouldn't it? Because then the logs will work. They won't work if we just did that. So theta minus 20 then is equal to a e to the bt. So logs of both sides. Log of this will equal the log of this, and this will be log a plus log of e to the bt, which is bt log e, isn't it? Okay, and log e is 1, so it's ln theta minus 20 is equal to bt times 1 is bt plus log a. So compare that with y equals mx plus c, and we can see the correspondence. The y is log theta minus 20, the x is the t value, and in this case m, the gradient has the value b, the intercept has the value log a. Okay, that's the information then, and that's the corresponding correspondences, so to speak. So we need log theta minus t. So let's do time. So t equals, because time is the x-axis, 0, 5, 10, 20 and 30. And then we've got theta, haven't we? And we need ln theta minus 20. When t is 0, we've got 100. 100 minus 20 is 80, so it's natural logarithm of 80. 80 equals 4.38. So I'll put that down then. 4.38. And then the next one, let's just try and get a bit more room. When it's 70, 70 minus 20 is 50, ln 50. ln 50. 3.91. At 10, theta is 50. 50 minus 20 is 30, ln 30. 3.40. And then the 20 value, which is when it's 30. 30 minus 20 is 10, log 10, natural logarithm of 10, ln 10, 2.30, 2.30, and the last one then, we've got 30 value is, the theta is 25, minus 20 is 5, ln 5. So, natural logarithm of 5, 1.61. So here's our data then, and it should be a straight line. So, excuse me, let's have a look at this. So draw straight lines. T is the x-axis, wasn't it? And log theta minus t was the y. So here's t, here's ln theta minus 20. We go up to 5, don't we? Just under. 1, 2, 3, 4, 5. And we go along to 30, don't we? So 5, 10, 15, 20, 25, 30. And this was up to 5, wasn't it? 1, 2, 3, 4, 5. Okay, so what have we got then? We've got 0, 4.38 here, 5 on the t, 3.91, 10, 3.40, 20, 2.30, and then 30, 1.61. Okay, let's draw a straight line then. So I'm going to do it from here, just draw it like so. That's a bit high, isn't it? So I'm going to take it down below there. Come down a bit and go there perhaps. That looks better between the points. So the intercept here is just about here, which I'm going to say is 4.3. The gradient, well, if we go along, say, to here, to 30, we've come along this much, haven't we? Let's just draw it straight across as best we can. So how much have we come down? We've come down from 4.3 to 1.5. So the height here, 4.3 to 1.6, say, is 2.7. That's 2.7 is the height down. We've gone along 30, so the gradient m is the increase is minus 2.7, and the x is 30. So m is equal to 2.7 divided by 30 with a minus 0.09. Okay, so with a minus, so that's m. So the gradient m is b. So b is equal to minus 0.09. And the intercept, which is 4.3, is equal to, let's have a look, log a. So a is equal to e to the 4.3, shift e to the 4.3, 73.7. So what have we got then? What was it? Theta is equal to 20 plus ae to the bt. Theta is equal to 20 plus a, 73.7, e to the b, minus 0.09t. Here's our model then, that we think, according to my fairly inaccurate drawing, should be the model. Okay, so now we need to work out the two problems that were asked. So go back up, and what were we asked? We were asked to find out theta when t is 15, according to this model. T equals 15, theta is equal to, let's tap it in then, 20 plus 73.7 times e to the power minus 0.9 minus 0.09 times 15. 39.1 degrees. That's the first one. The other thing is we're now told theta equals 60. What does t equal? Theta equals 60. So 60 equals 20 plus 73.7 e to the minus 0.09t. Take the 20 over there, you get 40. Once the 20's moved, we can move this from times down to divide. So now take logs. So minus 0.09t, this comes down to ground level, is equal to ln of 40 over 73.7. And then so t is equal to 1 over minus 0.09 times the log of 40 over 73.7. We can tap that in a calculator. So 1 divided by 0.09, the minus is at the front, times ln 40 divided by 73.7. Close that bracket, equals, and that's a minus as well, 6.79, 6.8, and that's to 1 dp. 6.8 minutes, presumably, is the units. Anyway, 6.8 units for that question there. In the solutions, I'm just looking now, we're told that we got 77 is the value here, and e to the minus 0.09 0.095, which is quite accurate. The answer for theta was 38.71, so that's quite close. And we get 7 minutes when theta. So these answers are quite close to the ones that were obtained in drawing a much more accurate graph in the solutions.